My name is Ashley, and today I'm going to be explaining the graphs, the position graph, the velocity graph, and the acceleration graph for a problem where a ball is thrown up in the air and then it falls back down and is caught. So we'll start with the position graph, which would look somewhat like this, and it is on the y-axis in meters, and in the x-axis is over time. So the ball will be thrown up here, and then it will slowly come to a stopping or come to a slow down point, and it will fall back down to the ground before it is caught. So the next graph that we'll talk about is the velocity graph. That is on the y-axis is velocity, and it's in meters per second, and the x-axis is time. So the velocity is going to be a straight line, a linear line, um, that is a negative slope from the positive to the negative. So it's in the positive, it is slowing down as it's moving in the positive direction, and then it stops for a second, and then it is accelerating as it goes in the negative direction. Okay. And then the final graph is the acceleration versus time graph. So we have the acceleration in meters per second squared on the y-axis and the time in seconds on the x-axis. And then this right here is our acceleration line. And the reason why it's just a straight line through the negative is because it is slowing down in the positive direction and gaining up speed in the negative direction, which would make the overall acceleration negative.